Hello, my name is Vishal Rein. In this video, I would like to talk about Polygon and Polygon Basics. So, what is a polygon? If you see here, we got some primitive models. If you go to the create, we have polygon primitives. We have NURBS primitives. So, I'm talking about polygon primitives. So, I'll take a sphere, and then if you see here, I got a model. Now, what is a polygon? Polygon is a closed shape, a closed surface or closed shape which is surrounded or which is bound by n number of line segments. For say, if I take this subdivisions of 5 in axis and height, I get a model here which has got something called face. Now this face is a polygon, and this polygon is of 4 sides. So if I select this one, this polygon is of 3 sides. If you take any other primitive, for example, I take a cylinder and then switch subdivision caps to 0 and axis subdivisions to 5. Now I got a model which has got a face, and the face has got 5 sides. So if I increase that to 8, then I get a face which has got 8 sides. So a polygon model is a 3D geometry which is made of different polygons, like a mosaic tile sculpture. We take small pieces of mosaic tiles and make a sculpture out of it. So this is like a mosaic tile sculpture for me. For making a decent good model, it is very important to keep the polygons in a sequence which we call as loops, and we try to make them work for our model. So try to understand the polygon model. So if I select the object here, right click on this, we have something called face. We select and then we got the face here, and that face can be selected and can be moved, can be rotated, or can be scaled. Okay, the total surface area of that polygon is called a face. And we have edge. Edge is a line segment which is surrounding this face. We can select that edge and then we can scale it, we can move it, or we can rotate it. We have a vertex. A vertex is the corner of the face. It's a point between these two edges. When we select the point, we can move that point. Rotating a single vertex or scaling single vertex shows no effect on the model, but we can select more than one vertex points, and we can scale, which is very similar to scaling the edge. So scaling the edge or the two vertex points results the same on the model. It's any method you can use here to do that. Alternately, if I select the 4 vertex points, then scale them, it is as same as selecting the face and scaling them. We can hold and select multiple faces there. It is also very similar in vertex selection and the edge selection. If you have selected multiple edges, by holding Control, you can deselect them. If you are in the component mode, we can switch back to object mode. We have a multi-component or multi-component. If you see, I've got the face, I can click on the edge, or I can click on the vertex point, which is not possible when I'm in the face. I can't select the edge there. It's not possible. But in multi-component, we can select a face, we can select a edge, we can select a vertex. There is no problem in selecting different components altogether. There are certain tools where we need a combination of face and edge, so we need a multi-component in that scenario. We have vertex face. You can't really edit this component here. Sometimes when we are dealing with something called non-manifold geometry or something which is not going correct, we can use this vertex face component and explore the model. We have a UV component, which is UVs, which we can select, and we can't really transform them in this space. There is a different space for it where we can transform them, and UVs are very much related to texturing. So when we do UV unwrapping, then we can discuss about that. So we can switch between the object mode and the component mode here. We can also use the keyboard shortcut F8 and then switch between object mode to component mode. In components, if you see here, we have different types of components. So we can select the vertex, we can select the UVs, we can select the edges, we can select the faces, and then we can switch to any of the components we have here. If you go to the select menu, we have object to component switching, which we have done here. We can use this option here, or we can press this keyboard shortcut F8. If you go to the components, we have multi-component, which is F7, vertex F9, edge F10, face F11, vertex face alt F9, UV F12, UV shell alt F12. So we have all this ways to select the components here. Let's understand the loops or topology concept. So here I've got three different planes. They look very similar, they are same models, but if we just have a look on their topology, general meaning is study of surfaces, but here in this context in 3D, how the lines of the model are flowing, we call them as topology. And topology is very important in character development, because the character, once we model them, this character go to rigging and animation departments where the character has to deform. So deforming models need to have good topology. So just have a look on this model here in wireframe mode and see three different models have three different flows. If we see the middle one has got no subdivisions. So when we are building something, we get quite often questions like, is it necessary to add lines in the middle or not? It depends on a few questions. Like for example, if the model what you're making is just a model which doesn't deform or doesn't get animated. For example, you are modeling a room and there's a tube light or there's a table which doesn't move or deform, and we only add lines which can build a shape. But if the same table has to be deformed, we see what kind of deformations that table will get, and then we plan the flow accordingly. So how do we understand what is the correct flow or not? So if you see this particular model, this model has got a vertex here and a vertex here, and there's no break in the middle. So what if I bend this model? So I'll just I've animated them to bend. So when I just drag this time slider, you see the middle plane is not taking the shape of what I'm really expecting. So it is same plane maybe by looks, but by topologically they are not same models. As every vertex, I'll just take a polygon plane, and then if I have to bend this plane, I need to select the vertex points, and then I just set the pivot point at there, and then rotate, and then you see you got a bend, right? As there is a vertex here, that straight lines, there is an angle getting affected, and we are getting the bend of the model there. If there is no vertex, you don't get that bend here. So our polygon models are of straight lines only, line segments. They are not splines. So if you feel that it looks round, but still it is straight lines, but more number of lines make it look more rounder. So when you are making a low polygon models are generally done in games to compensate with the rendering and compensate with the real-time rendering, and polygon count is more than it can be lagging. You may not get the real-time moments there, as game engines show real-time outputs. So they prefer to go with low polygon count model. Polygon count is nothing but you build a model with a certain polygon count. So this model has got 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So you got 10 polygons model here. So we get that prerequisite of the model, like we have to model our model in, let's say, 1000 polygons. It should not cross that. So in that conditions we use limited numbers, but at that time it is very hard to get the silhouettes more round. So yeah, it's challenging. You model, but you have more conditions while you are doing model. So it's but whereas feature film don't really care about polygon count, but they focus more on the output. They don't hesitate to invest more polygons into a model. And here is one bad topology model, and it's made with polygons which are of different shapes, if you could see. So they are not generally when we build a model, we mostly prefer to take a four-sided polygon. We call them as quad. Its full name is quadrilateral. If a polygon which has got three sides, then that polygon can be considered as triangle. Don't think this is a triangle here. This is a four-sided model only. You could see 1, 2, 3 and 4. Maybe I can just switch 1, 2, 3, 4. So if I'm using a polygonal face which has got three sides, we call tris or triangle, four sides quads, anything which has got more than four sides we call them n-gons. So when we are modeling, we take care of not using n-gons. Mostly we use quads. Triangles can be used as far as the models are not deforming. You can use triangles because if you see right now this model, the polygon count, if I say it has got one polygon but it has got two triangles too. I go to the display, heads up display, polygon count, and then if I select the model, this is the selected models component count. So twice you have two here. So you might be thinking, where is the triangle here? But actually there are triangles. So these are the two triangles in the model. So even though you made a model with quads, your rendering software will consider them as triangles only. So triangles are not really your enemy, but generally when you're deforming or building a flow for the model, quads make your life more easier. That's the only reason you're recommended to use quads while modeling. We'll try to understand the polygon loops here. So what is a loop in a model? So loop is a sequence of polygonal faces, and especially the faces should be four-sided faces. So if I am like selecting this way, this doesn't count as a loop because when I'm selecting the faces should be parallel to each other. Now if I select this one, this is not a parallel face for the previous selection there, so this is not a loop there, and loop will always go that way. So not necessarily the loops will be in straight line. We can take control over the flow and we can change the loop accordingly. For example, I want to take the loop flow going this way. It is very easy to do that. For that, I'm going to use a tool called multi-cut tool. Okay, I'm adding a line which runs in the middle, and then here I'm taking a turn, then go straight, then take a turn, then come back. Now at every turn, and this is a very common combination, at every turn you get a triangle and a pentagon, a five-sided face. Triangle, a five-sided face. It is very easy to fix. This triangle has to be split in the middle, and then in the opposite corner just connect it. Now just I move the point so that the shape would be much clear. Now the combination of triangular pentagon are gone. Now I got a combination of three quads. Now if I select the face, now they go in a loop. So I've built a model whose flow is going a U-turn. Now to check whether we have really made a flow, I'll be using a tool called Insert Edge Loop tool and click on the line here. Now this line will be created only when there is loop. Okay, the loop flow, the line will go accordingly. So we'll click here and let's see how this line will be created. Now see, that's created in the direction of the loop. So we see the loops in modeling, how they are flowing, and according to the deformation we try to build the flow of the model. The flow of the model, what we are talking about, is called as topology. Topology is nothing but study of surfaces, but in the context of 3D modeling, it is all about how the wireframe on the model is, how the lines are going. We see all that.